Hey everyone, how's it going? It looks like people are still filtering in, so we'll give it another minute or two for people to jump on, and then I'll jump into it. Hmm. All right. Sorry about that. My camera is malfunctioning right now, but we'll get on with it. Hi everybody. Make sure you can hear me first. Yeah. Hi everybody. Welcome to our first of these monthly Getting Started with Pinecone webinars. I'm Gavin. I work over at Pinecone. I'm a product marketer over here. And yeah, I'm going to just take you guys through just real quick how to get started with Pinecone Database and with Pinecone Assistant today. So let's jump right over into it. So first off, I'm going to just review what Pinecone is. I assume most of y'all will know because I think almost everybody on this call is signed up for Pinecone. But just review real quickly, just make sure everybody's on the same page and we all understand what Pinecone and vector search is, and then jump in the demo real quick. But first, before we get into that, uh, just who here knows what a vector is, or how they're created, or how that leads to making search semantic? Um, it's not as straightforward as some of the other search options or lexical search options that you've seen floating out there. And the way vectors work is that vectors represent many dimensions. So a vector is a numeric representation of whatever your source data is. And it's stored as a list of numbers. Um, and the idea is that you can graph these numbers onto, like, or plot these numbers. So if you think about it simply as like two dimensions, x and y, the way a vector is graphed would be the x and the y coordinates, and that's your point on the graph. If you think about three dimensions, it's like a 3D graph with x, y, and z coordinates. And you can graph those and put your point on the graph. But when we're talking about vectors that you put in a vector database, we're usually talking about significantly more dimensions. Like, it's really easy to think about two dimensions or three dimensions because we're very used to that. But it's very difficult to think about like 1,500 dimensions or something like that. But mathematically, it's still a thing. And that's what a vector represents, is basically a point in a extremely multi-dimension space. Now, how do you get vectors, right? How do you actually turn words into this? So you all are probably familiar with LLMs. You take an input, a prompt, and you generate an output by predicting the next token or the next text, right? So the idea here, or the example here is, that song, I'm never gonna, and if you put that into a generative LLM, It's going to come out with the next predictive thing, which is give you up, because that's a very famous song, and those are the lyrics to it. An embedding model is not predictive in that way. You still feed input in the same way, but instead of spitting out a prediction of the next series of tokens, it takes those and converts them into a vector embedding, basically a vector that represents the meaning of what the input that you put in is. So the embedding models convert meaning into actual vectors. And the way they do that's quite complicated. I won't get into it today, but that's what they do. So that's what they do well. Great, we have a bunch of vectors. What does that really mean? So these vectors, because they group things by meaning, they make it so that we can do semantic search in a relatively straightforward fashion. And here's kind of an idea of what semantic search is versus text similarity that you get from like a regular lexical search. So if you looked up these three things, where is the Bank of England, where is the grassy bank, and how does the plain bank? The word bank is used in all three, but bank means different things strongly in every single one of them all the way through. So when you look at where their vectors, where the actual like point for them in that multidimensional space would be, they're far apart. They're not similar. They're very different, even though the words are close. But if we look at the bottom example, the bees decided to have a mutiny against their queen, and the flying, stinging insects rebelled in opposition to the matriarch. If we look at those two examples, those are very different. The words are incredibly different, like not the same at all, but they mean almost the exact same thing. So the vectors that we map are going to be mapped very close together. So that's what that's how semantic vectors work. Things that mean the same are grouped close together. Things that mean different are grouped far apart. And the way that we find results for search results is we look for things that are close. So you'll see your here approximate nearest neighbor and things like that. And that's what it is. That's like the mathematical formula to actually figure out where in these multidimensional spaces the closest neighbors to us are. Okay, so that's what vectors are. That's what semantic search is. What's Pinecone? Pinecone, we're the industry-leading vector database for building accurate, low-latency AI applications. We're extremely versatile, more versatile than many other vector data stores. But the primary use cases that people come to us and want to use us for are hybrid and semantic search, recommendation systems, and RAG and agents. Those are the big three that we get a lot of workloads for. Each of those has vastly different requirements, though. In most vector databases and search engines, you have to have trade-offs around accuracy, performance, and cost to really balance that out and make sure that you can satisfy those use cases. And some of those trade-offs can lead to degraded performance and accuracy, or it can lead to increased operational overhead and total cost of ownership because you're having to manage all of this, all of these trade-offs. These are all knobs that you have to like adjust. Or frankly, just delayed time to market because the system can't perform or because you have to spend time figuring out how to make it perform. But Pinecone's purpose built for unstructured data. Like this is what we do, this is what we're built for, and you don't have to make those same trade-offs. And you can bring any type of knowledge to us for your any AI workload. So we can take in any type of data as long as it can be converted to an embedding. We can take it. So text embedding, super easy, tons of embedding models, image embedding models, audio embedding models, video embedding models. You can extract text and embed it with a text embedding model from videos and audio too. There's a lot of ways to actually get the data that you want out of your content and out of your media and into Pinecone, into a vector embedding. And as far as embeddings go, you can use a model that you are already using. Maybe you're hosting it, maybe you're getting it through a different like LLM or model provider. But we also have several integrated hosting options as well. So you can just get it with us too, with using the exact same API and don't have to like set up new accounts and all that. We're mature. We're one of the more mature vector databases on the market, possibly the most mature. And with that comes a lot of integrations. We have, I believe, over 100 integrations with different tools. So we have a lot of integrations into the tech ecosystem. We have things like, we have ways to refine retrieval that are just very good and that other vector databases suffer with in different ways. So one of them is we have native re-ranking. So we host re-ranking models and you can re-rank. If you do two different types of searches and need to combine the results, you can re-rank inside of us with a simple call to an API. We have metadata filters that are capable, and we have namespaces, and we have good namespace support too. Some vector databases have trouble with like high namespace support. We can scale like well north of 100,000 namespace. I believe you can go up to 1 million if you ask the salesperson. And that's great for multi-tenancy. Namespaces, when you think of namespaces, think of multi-tenancy. And we scale. We can scale to billions of records, thousands of QPS, and we're currently doing it on workloads for large companies. Our serverless architecture is the reason that we don't have to make these trade-offs and the reasons that we can scale like this. So you've probably heard of like the separation of compute and storage. We do that. We separate compute and storage, but we go beyond that. We actually separate reads from writes, and those completely from storage. So that way, if you're having any resource contention between reads and writes in other systems, that's not something you're going to run into with us because reads are on their own path and writes are on their own path. Uh, our architecture is built in such a way that it allows scaling with very high levels of accuracy and low latency. Like that's how we're built, and we're built in a way that's different than any of the other vector databases are built right now. And we're the only ones that can provide that currently on huge data sets. Like usually accuracy will decrease, your latency will get higher when you get your data sets larger. But with us, you don't have to trade off either of those. Accuracy will maintain and your latency will stay low. And we're accurate at massive scale. So we have high accuracy, predictable low latency at high QPS, and we're built for scale and production and are already in production with a lot of major companies doing massive workloads on us. And lastly, before we jump into the demo, you can get started with Pinecone like whatever way is best for you. So if you go to our docs and go to our quick start, we have the traditional code first quick start with full code walkthroughs, code snippets, and steps to get you started building on Pinecone. But recently, we've also built out some AI-assisted quick starts as well. So if you're using Claude Code or Cursor, I believe you use Codex too, because it uses agent.md. You can just download our agent.md or claude.md file, and your coding assistant will automatically have best practices to work with Pinecone. So if you're using a coding assistant, we're super easy to get started with and keep things high quality in terms of code. And lastly, we have no-code development integrations too. So we have integrations with NAN and Zapier and some other no-code tools. Those are the two big ones, though, that allow you to ingest data into Pinecone and then push Pinecone data into LLMs, all without having to code a single thing, which is kind of nice, actually. Okay, let's get to the demo. This is the part I want to do anyway. All right, so the demo I'm working on today, I will show y'all the repo for it, which will be, oops, there you go, which will be linked in this, and I can send it out later too. So there's a Getting Started with Pinecone webinar repo. This repository has example code for loading data into Pinecone Database, like our straight vector database. Oh, sorry, I think I stopped sharing. As well as loading code into Pinecone Assistant. So there we go. Oops. Sorry about that. I shared the wrong thing again. Okay, there we go. All right. Sorry about that. Here's the repo for it. You can get it right here. It's github.com/pineconeio, and it's Getting Started Pinecone, or you can just wait until after I link to it as well. This repo has example code for loading data into Pinecone Database and then querying that data as well. So we'll build a query here, and it has example code for loading data into Pinecone Assistant, and then pushing out prompts to Assistant and getting responses back. So we're going to go through both of those briefly today, and I'm going to kind of show you the different things you can expect to run into when you're building on Pinecone, or the different things you should need to know so it can help you get building easily. So one thing that is extremely worthwhile to think about here is when you're choosing, if you are choosing between database and assistant, the data loading, first off, they deliver two very different things. Database delivers search, semantic search, as well as sparse lexical search. So you can do search on database. Assistant is basically kind of like an easy way to make an LLM that has Pinecone database's RAG. You upload documents to it, and those documents basically are your RAG, but instead of using full document RAG, we're using vector database. So we're converting those documents into vectors, storing them in Pinecone database, and then returning those results to the actual assistant. What it does is it makes that assistant extremely, extremely knowledgeable on the corpus of information that you put into it. And it also restricts what it knows, like its knowledge, to the corpus as well. Or more or less. It knows more, but it won't go into deep detail on things outside the corpus of knowledge. So you get something that's extremely expert in the data that you input into the system or that you upload into Pinecone Assistant. Um, I'll show it to you. It's extremely easy to use and like really cool, but I'll show it to you in a second. The important things I want to note from a data loading standpoint is that for Pinecone Database, like you don't just upload documents, like you upsert vectors. Like that's what you do. You insert or upsert vectors into Pinecone Database. What that means is wherever your data is coming from, you're going to need to load it into your program. You're going to need to transform that data, most likely, because most likely or depending on the type of data, especially if it's structured, you're going to want to put it into more of like a textual format before you send it through an embedder, or else it's going to get it's going to get worse results. So there may be some transformation necessary. After that, you have to chunk your data. So because you have to run your data through an embedding engine, right? Through an embedding model, they only accept so many tokens, and those tokens are far, far less than you're seeing in a lot of LLMs. Like, you're talking like 500 tokens or 2,500 tokens, not like 1 million tokens or 20,000 tokens. So much smaller. And you have to chunk your data to fit. So you have to actually go through and chunk your data into the appropriate size chunks. And then you usually want some overlap too. So there's a lot of competing ideas on the best way to do that. We actually have articles in our Learn section of our website about how to chunk data and some of those best practices. But that's something you have to do. And then you have to take that data, the chunk data, and embed it, actually send it through the embedding model. If you're using our integrated embedding, which we offer, you don't have to send it through an embedding model. It just does that for you automatically. But if you're not, if you're bringing your own, you have to send it to an embedding model before you can upsert vectors. So there's several steps in database. Assistant is much more straightforward. So there are some supported document formats. So if you're bringing data in the wrong format, you may have to change it. So that's like a restriction, but also it makes things very easy. The other part is that you need to split any files that are north of 100 megabytes. 100 megabytes is the file size, like upper limit that we support. You can upload as many files as you want. So if you have, a gigabyte file, you're gonna have to split it into 10 files. So there's still gonna be some level of like data manipulation in the background. If either A, you're using a document format that isn't supported, or B, you're using files that are too large. For most cases, unless it's like a very large use case on Assistant, most people don't have to deal with either of those. They may have to convert if it's in like CSV, but that's about it. Most people don't have to split large files, but that is something to be aware of. Okay, stepping back into the demo. Let's jump into database, how you actually insert data into Pinecone Database. So I have a database directory here, and I have a load method, and then we can just look at this main. And if we want to, we can jump up further. This kind of explains what you need to do. So the first thing that we do is I have a utility method as well, or a utility class, or sorry, Python file. So in this utility file, the first thing I'm going to do is I'm going to get indexes. So what is get indexes? What get indexes does is with Pinecone here, I am implementing hybrid search. You may see it referred to as cascading search in some places. That takes dense semantic search, which is what we specialize in, and combines it with sparse lexical search. So, like straight word search or keyword search, as you'd see. What we do is we insert all the data into both of the indexes. We create one index for each. We insert all the data into both of the indexes. When we query both indexes, and then we merge the results and re-rank them and return them. A lot of times, this returns much more accurate results because results frequently are, when people are searching, are a mix of lexical and semantic. A lot of times they'll want meaning. Sometimes they'll want specific like keywords or word sentences. So doing hybrid is generally a more accurate approach, especially if you're doing like regular search or RAG. So we're doing that here. We're implementing hybrid search. So we have to have a dense index and a sparse index. So that's what get indexes does. If the dense index and sparse index don't exist, it will create them. And it pulls the names from an env file. So that's the first thing. We go out and we get our indexes that we're going to insert into. The next thing that we're going to do is we're going to go grab our data. So the data I used was I went on Kaggle and I pulled off all of these games as well as reviews from Steam, the video game store, as of like September-ish. It's north of 250,000 games, north of 1 million reviews. And I inserted that into Pinecone Database as well as into Pinecone Assistant. So that's already done. But during the process of it, I actually pulled both the applications data, that's what they call games, applications data, and the reviews data into a pandas data frame so that we have all that data loaded up into our Python program. We can manipulate it because it was in CSVs. And CSV isn't a natural format to run through an embedding engine, so that some manipulation was needed. Uh, so the next thing I did was after I pulled these in, I did transformations on them. So I transformed the application data and then I transformed the review data. And when we go into this, we can see exactly what I'm doing. Like I'm pulling out specific columns from the data and then I'm building a string based off those columns. And that's the string that we're going to send through the embedding engine. Uh, and reviews very similar. I went through and I pulled the data. I pulled out certain columns that I wanted. And then I sent them, or I combined them into more of like a paragraph or sentence style format. And we can use that to more easily or more effectively embed this data than if we just spit it as straight CSV data. So that was the next thing I did. And then the last thing right after that is to upsert. So I'm using our embedded inference. So sorry, our integrated embeddings. So that way, when I call this upsert, I don't actually have to send any of my data through an embedding model first. The upsert will automatically take care of it. Same on the search side. When you search, you don't have to, usually when you search, you have to embed the search so that you can pull out the data from the database because that's how it looks for stuff by the nearest neighbor. So it needs the vector. Uh, but if you're using our integrated embeddings, you don't have to worry about that at all. You can upsert and it will automatically embed, and you can read in your query and it will automatically embed your search string as well. So I didn't have to do the embedding piece. I just got to go straight to upsert. And then I upserted reviews as well. So just ran 2 big upserts, and this was, what, close to 2 million records or 2 million vectors. So that's the load. The full code's here because there's, complications behind some of the transformation. So if you want to go and look at it or you want to use any of it, you can grab it. But let's jump into the query too so we can see what it does. So the query is extremely straightforward. You literally stick in a query string and then a mode because I've implemented so that you can search hybrid, sparse, so lexical, or semantic. So you can choose which one you want. It defaults to hybrid. And then top K, the number of results you want returned. If you send that in, it will choose the mode. Since I was talking about hybrid, I'll talk about that. It will then query the dense index. It will query the sparse index. It will return the results and it will fuse them. And then it will run those through a reranker that's hosted on Pinecone. So yeah, that's how that works. Let's see if I can jump into, yeah, there we go. We can see what the re-ranking does. So we can see here, I did a lexical search and got the results on that. I did a semantic search. I got the results on that. I merged them, put those into one list. And then I sent the merge results, or I cut the merge results list down. You usually search a little bit more. So I cut the list down to like the number that we wanted. And then I got our Pinecone environment and then sent the results into the re-ranker in Pinecone. So we re-ranked it. I mentioned all this before. This is how hybrid search works, but this is implemented so you can go in and pick it up and just straight up use it too. And now let's go and actually look at what this does. Okay, so if we come down, we have some example queries that we can run here. So here's querying the database. This is just using regular, good old-fashioned hybrid search. So I'll run that real quick. So I'm looking for action games with good graphics. So it's looking across the data from the games as well as the data from the reviews and trying to pull across everything that is action games with good graphics. And it just spit out 10 results, which is the default number. If we want to go and look up at the top result, let's see. It's a game called Marlene Betwixt. Interesting, never heard of it. but probably because it's so general, it's just looking literally for like a very, very simple thing. If we got a little bit more complicated, it would probably be easier to find results you'd expect more. But it returns results based on the game description as well as the reviews. So any of the data in the reviews. And these are the top 10 games from that list. If we want to look at more of just a straight semantic search, so drop the lexical piece, we can do that with the exact same search. And this just looks at the dense index only and returns the results. And then if you want to see, we can do the same with lexical as well. But I'm going to skip that just for the sake of time. So here, that is when we do it with just semantic, the one that returns back is fast action hero, which totally makes sense because we're looking for action games. Action Legion. So this all makes sense. Like when it returns back semantic. Are these results better than the hybrid ones? Probably not. But these are the results that come back when you search semantic. So this little example has the flexibility, and I hope you all go out and play with this afterwards too. I've already preloaded the data and given you a read-only API key, so you can actually just go and hit the vector database as well as the assistant that I've created too with this exact program. So I'm hoping you'll go and play with it and try this out. But before we get to that, let's jump into Assistant real quick. If you all aren't familiar with Assistant, if we go into Pinecone, I have one built. This is the assistant that I'm showing you today. So it's a Getting Started webinar assistant. You come in, you can give it instructions. This interface is mainly for testing. So this chat model you can set in here. When you actually use it via the SDKs, you have to set the chat or the model every single time that you make a prompt. But it's still very simple. And in here, you can look at literally all of the files that are uploaded. Like they're all there. You can delete them. You can go and look at them. You can pull them open if you're in the actual application. So I'm going to show how I actually went about loading these. And the loading on this was simpler, significantly simpler. So if we go down and look at how we want to load, I'm getting my assistant. So this is the same. I'm calling Pinecone and pulling back the actual assistant object. All the data sets in Steam were in CSVs. So if I actually pull open the data folder, you can see they were CSVs. And they're large CSVs. This application one's like north of 100 megabytes or something like that. So I already lost my file. All right, so and the big thing is Assistant doesn't accept CSVs. Assistant does accept JSON though, and it's extremely easy to convert CSVs into JSON, so that's what I did. I just ran a little method to convert CSVs into JSON, and as part of that method, I split those files up into 100 megabyte files so that we wouldn't run over the size limit. That's the reason you're seeing so many reviews and so many application files here. So these are broken up into 100 megabyte files. They're JSON files as CSV now, and thus they can be uploaded to Pinecone Assistant. And then all I did was upload files. That's it. It uploads them, it processes them, it inserts data into the database without you ever having to see it or know about it. It does all the calls out without you having to see it or know about it. So real simple. And then the prompt on this is also very simple. All you really need to send the prompt is whatever the prompt is, as well as the model. That's it. And the model will default to GPT-4o if you choose nothing. So if we jump back over to the README, there's examples in there of how to call this from the command line too. So I can jump down to this one right here. Let's even look at this. I'll use Claude 3.5 Sonnet. So I'll do one that's using Claude 3.5 instead of ChatGPT and see what it tells me about Counter-Strike's review sentiment. And this one takes a second longer because it's actually running data through an LLM too. So it's waiting for the LLM response before it kicks it back to you. So expect Assistant to be slower than database. Actually should return here in just a second. But while that's running, since we're running out of time, I'm going to show you guys a few other things real quick too. So at the end of this webinar, there will be links to number one, this GitHub repo. And notice that I am giving you a read-only API key so that you can play with the actual data that's uploaded into it, as well as the assistant that's on it too. And I will also be sending you all this URL too. And what this is it is the getting started assistant that I showed you back in the Pinecone console. That's what it is. But it's publicly facing. So it's just a UI built on Next.js that exposes the Pinecone assistant. So you guys can play with it too. And I'm going to answer some questions here in just 1 minute. I'm just trying to make sure we cover this last bit. Okay. So the assistant response came back. And let's see. So it gives you the actual sentiment from the reviews. And this, see, I can provide insights into review, which seem to be most recent iteration. So mixed reactions, it tells you what those are, the positive aspects of it. It tells you about it, and it gets into like the negative aspects, and some specific things. So this is probably not super worthwhile to most people, but it's a really good example of how you can take some data like reviews and even descriptions of items and turn them into really, really worthwhile data in an LLM using Pinecone and Pinecone Assistant. Extremely easy to stand up RAG with Pinecone Assistant. So there's that. I'm going to stop sharing now, and it looks like we have a few questions. So I want to jump into those. Let's see. Oh, that is a note taker. We can ignore that one. Can Pinecone be used on a Microsoft laptop as well? Yeah, absolutely. Yeah, Pinecone is completely agnostic in that. We're a serverless database, so our SDKs are language specific. We are not operating specific in any way, shape, or form. So you can absolutely use Pinecone on a Mac laptop. Or on a, sorry, Microsoft laptop. Are there any other questions? If there are, feel free to throw them into or let's see, does anybody have a hand raised? If anybody has any questions, feel free to raise your hand. I can unmute you, and you can ask questions, and I can answer for you. Or you can leave them in the chat too. Either way is fine. Yes. Yeah. So in NAN, we have a Pinecone Assistant, or sorry, a Pinecone Database node right now. It takes care of a lot of the stuff that I just mentioned. So remember how I said you had to load data, you had to, chunk data, and then you had to embed data and upsert it into Pinecone. With the nodes, you don't have to do the chunking or any of that. It loads the data from wherever you pull it from, it chunks it for you, and then you can insert it into Pinecone. So yes, we do have a node in N8N. We also have a node in Zapier as well. And we're coming out with a Pinecone Assistant node in N8N. I believe it should be out like this week or next week. I think we finished work on it last week. I think it's going through approval with N8N currently. Does the vector number always differ for the same text? So are you talking about the number of vectors returned? Do you want to talk, Mansur? Do you want to ask a question so I can get a little bit of refinement on what you're asking?
Hello?
So there's a couple ways that I can read this, man. So you're saying, do the vector numbers always differ for the same text?
Yes, correct. So when we're doing embeddings and it's converting into the vector numbers, does those numbers are different or they always still the same?
Oh, so let's say you take the exact same sentence and run it through the same embedding model.
Yes, correct.
It'll be the same.
Mhm. So it's kind of like a hashing, right?
It's kind of like a what?
A hashing when you're translating.
Kind of, yeah, kind of. Not too different. All right. Did you mention if Pinecone Assistant can integrate with re-rankings and citations? So Pinecone Assistant doesn't need to integrate with re-rankings. Pinecone Assistant by default uses hybrid search. So it uses dense and sparse vectors and it runs it through a re-ranker. So it does all of that for you and it supplies citations. So Pinecone Assistant does all of those things that you're requesting. You don't need to integrate them. Let's see. Is there a possibility to use NLP to work on Pinecone similar to Supabase Agent? I'm not familiar with Supabase Agent, Rajiv. I'm going to unmute you and you can ask me like verbally, and maybe we can figure it out. Just, let's see, there we go. All right, Rajiv, believe I unmuted you. Yeah.
I tried to create a RAG agent using a Superbase for vector database,
Okay.
and um, I was able to like use NLP to kind of ingest the data and kind of break it down into vectors. So, I mean, is it somewhere in the product roadmap that the connection between for non-coders who are product managers, they can, because they don't understand these the code,
Mhm.
so will they be able to use NLP to integrate Pinecone into the front end
I
down the.
mean, I understand what you're saying. So like it's basically for the data loading process, you're using some natural language processing to get the data in the shape you want. Is that what you were doing?
Yeah. Correct.
Yeah. So
Yeah.
one, you absolutely can do that. We don't have any NLP like built into our SDKs or anything like that, but you can absolutely use NLP to get it in the shape that you want. I have actually, I was playing or I was building a POC, just trying something out with Assistant the other day, but it would work very similar for database. And I was using not even NLP, I was using OpenAI models. So I was taking transcripts. I was sending I was taking video files, extracting audio, sending it to OpenAI, transcriber, getting those transcripts and doing more work on that. And then also sending like 1 frame per second images to ChatGPT, to OpenAI as well, to get like verbal or descriptions of the actual movements and like what's happening in the video itself. And then combining that into like a JSON file that's very text heavy or a bunch of related vectors in the database if you want to go that way. And I was doing that all using, LLMs too. So you can absolutely use any tools you want. The data handling before it gets inserted into or upserted into Pinecone is flexible as you need it to be. Like if you can do it in Python, you can use it with us.
Okay. All
Or
right.
take your pick of language, not just Python. We have a bunch TypeScript. We have a bunch of different SDKs. So if you can do it in whatever your language of choice is, then you can absolutely do that and apply it before you upsert it into Pinecone.
Got it. Thank you.
No problem. Any other questions? All right, folks. Thank you for your time. I appreciate it. Before I go, actually, I'm going to come into the chat and I'm going to post these links so that y'all can get to them really easily. And then I will see about sending this out afterwards as well. So the links I'm going to send you right now is our GitHub repo, the one that I showed you, which includes the read-only API key. I'm going to send you the Getting Started webinar public site, so the one that you can chat with our assistant. I'm going to send you the data set, a link to the data set that I actually used too. So I'm just going to insert all of these into the chat real quick. Oops. So first one coming through right now, this is the GitHub repo. Second one coming through is the public facing assistant site. So y'all can chat with the assistant that was built based off this data. And the last one is the data set too, in case you want to download it and play with it yourself. So there are those three things. And before we jump out for the day, the last thing that I want to do is just put this up here. Come join our community on Discord. We have a Discord community now. I just started a month or two ago. Y'all are invited. Come join. You can scan the QR code. You can click the link when the deck gets sent out to your choice. And learn more about Pinecone and our docs. I mentioned the quick starts earlier and how we have the three different versions of those now, or the versions for the type of coding you like to do. Jump into our docs. Play with the quick starts. Play with Pinecone. Learn about it. Yeah, it's really cool. It's a really useful thing, and it's nice. Looks like there's a few more things in the chat real quick. Let's make sure we got everything. You absolutely can get the PPT. It will probably come in PDF format, but I think the links are clickable, and I will send it out to the list after this call. All right, folks. Have a good day. Thank you for coming. I really appreciate it. This was a good first getting started. So thank y'all for coming. We're going to be doing another one next week. Y'all probably don't need to come to it, or next month. Y'all probably don't need to come to it. But yeah, use Pinecone, stay up on it, and it's really cool. I think this is a good way for you to make your careers more solid in the future. If you learn how to use vector databases, you're way ahead of the curve, folks. So keep it up, and nice to talk to y'all. Hope to see you soon.
Yeah,
Bye.
well, is there a part two,
What's
or
that?
is there a part two, or like a future of after getting started? What's going to come? Is
I have
there?
not planned that far in the future, but it sounds like we just got a request for a part two, so maybe.
All right, all right.
Yeah, no, this is the first one of these getting started ones that we've done, and we're going to do these monthly. But we are planning in the new year to expand out webinars too. It's just I'm undecided if we should go into like a part two, like going deeper, or if
Like
we should
some
go
use
into
case.
like a higher, like more like what is vector search and stuff like that,
I mean,
like in
I
more
was
depth.
thinking about something like some use cases. Any use case that you could, I mean, display or something that we can discuss
Yeah.
hands-on. Yeah.
Yeah, actually, that's a great idea. We have a bunch of case studies available, and all of those use cases are ones that we can show examples of and give you like specifics about in terms of performance and stuff like that. So that's a great idea. Thank you for the input. And when I email you all, feel free to once again give me that input as well. If you all want us to present a webinar, if you want to learn something about Pinecone, like let me know. I will try to make sure we can get you guys what you need.
Thank
All right,
you.
folks. Have a good rest of your day. Hopefully, I'll see you soon.
Good night.